So what we want to do in this video, I just want us to master um, the number system. So there's this thing that, like, the very first thing you do, remember that your computer science is going to have 10 topics to do, right, Alex? Now in the 10 topics, the very first thing you have to know is what we call data representation. Okay? The very first thing you need to know is data representation. Then from there, you're going to master the rest of the stuff. I'll be making you understand whatever I'm going to do. I like to start with the part of computer science which involves calculations and stuff. It's a very fun part. And I want you to make sure that whatever paper you're going to get, whatever paper you're going to do, you get all those marks. Are we together, Alex? All right. So I want you to know that when we're working in computer science, when we're working with this, we have 3 number systems, okay? Okay? When we say we have a number system, we'll be saying, I want you to know that it's, let's say, for example, we take real life. What numbers do you know in real life? This is chapter 1 that we're doing right now, which is called data representation. And it's mostly about calculating. It is going to have a little bit of theory that I'm going to cover with you. So chapter 1 out of 10, and chapter 9 or 10, or chapter 10 as well. These are the chapters that are going to have calculations. So I'm going to make sure I do those first, and then when you're done with those, then we can do the other ones. Are we together, Alex? So, okay, great. What we start with here is this very first one, data representation. We want to see, I'm going to take you through all those questions, those past paper questions, and let me go through them just to show you. Like a question which is going to be like this. Convert, this is from exam papers. I just clipped it from the exam papers, the recent exam papers. It says, each ticket number is stored as a binary number in the ticket machine. Then they give you like this. Then they say, convert the 2 ticket numbers from hexadecimal to binary. So they'll give you these ticket numbers, this one, and they want you to convert from hexadecimal to binary. Do you see? Okay, they want you to convert from hexadecimal to binary. So these are the things that I want to make sure you know. Once you know, then it's going to be very easy. Once you know, it's going to be very easy. So we're going to do a lot of these. We do a lot of examples, and we'll see how to do. Are you ready? All right. So here is how it goes. I want to explain something to you. So it's data. What we are doing is we want to see how we're going to convert from this one called hexadecimal to another one called binary. Then you're going to meet the third one, which is here, which is called denary. So there's one called denary. Then there's one called hexadecimal. And there's one called binary. These are what we call number system. It's a method of writing numbers. So when we say we have a number system, these are methods, the methods that we have of representing a set of numbers, okay? There's the one which we use in real life, which we use in the everyday system, which we use when we are numbering, and it's called denary. It's this one, the denary, where we have 100, we have 200, we have 300, we have 600, we have 1,000, we have 50, we have 75, we have that. That system is called the denary number system, but it's not the only one. We have another one called the binary number system, which computers use. Okay. Okay. So specific, it has the computer has its own way of the very same number that you know. You understand 600, isn't? You know what 600 means, huh? If you look at 600, you know what it means. To a computer, it doesn't look at 600 like this. For a computer, it doesn't look at 600 like this. This is meaningless to it. A computer will express 600 as ones and zeros. 1, 0, 1, 1, 0, 0, 1, 1, 0 like this. Yeah? You know, doing something like this. This is how a computer will be representing the same number. Do you understand now? So we want to learn the 3 different ways of representing numbers. The computer uses binary to represent the same number, 600. And we use denary, of course. We need to see it as a 600. Then there's the third one, which is going to be called hexadecimal, which we'll talk about and see what function, why is it even there? When is it used? But it's a different one so instead of writing 600, it's going to be, we're going to take this very same value and change it and write it in a different way. Are we together? Right. So let me make you just do this once. I want you to know that when we are going to be doing any conversion between binary, listen to the rules. Remember, the secret to you getting anything The secret to you mastering anything, the secret to you getting anything correct is to stick to the rules. Don't break the rules. So if you, whatever rule I'm going to give you right now, whatever rule I'm going to give to you, don't break it. That's the secret to getting it correct. So just listen to the rule, and when we do the questions together after I give you the rules just now, you should be able to do all the questions because we'll be just applying the rules, right? So I want you to know that when you are going to do any conversion between binary and denary, so binary is the number system which only involves ones and zeros. 1 0 1 1 0 0 0. It's a way of representing a number. So instead of writing 1,000 or 1,500 or 2,000 or 2,500 or whatever you want to represent, any number you want to represent in binary, it's going to be represented like this, as ones and zeros. You know, it'll be just ones and zeros. It'll be the very same number that you call 600, but it will be written in this way. So we are going to see, all right, so we're going to write your 600 in this way. Yes, oh, that's crazy. For you as a person, you can't see what number this is, but you're going to be able to convert it to denary. When you convert it to denary, now you'll be able to know what number it is. Are we together? So what we want, something like this. So whenever you want to convert between binary and denary, you must know that their relationship is going to be the values. Whenever you do binary and denary, Alex, you start putting on each value, and you start like this. You say 2 to the power of 0. Okay, 2 to the power of 0, what do you get? Any number to the power of 0 is 1. Okay, so what I want you to know is when you're going to get a number, let's say 1 0 1 1 0 0 0 1, like this, we are going to go to this number, and we're going to start putting values on top of every position. Okay, so we should create a table, and this table is going to work for us, which is going to be like this. This is the table which we put it on top. So it's like you say, here's how you start, Alex. You start at 1. Then you say 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. 64 times 2 is 128. Okay? If it ever gets bigger, it will get to 256. But it's growing up like this. Are you seeing it, Alex? So whether we have the binary or we don't have the binary, we are going to write, this is the secret. Listen, the secret to any conversion between binary and denary is this one. 1 times 2, 2 times 2, 4 times 2, 8 times 2, 16 times 2, 32 times 2, 64 times 2, 128. You should just write it from your head. Remember, you are not allowed a calculator for your IGCSE computer science exam. Are we together? So you should just remember this. This is going to be the secret. We are going to use this to do all our conversions between binary and denary. Are we together? So no matter whether we are coming from binary to denary or from denary to binary, what is the first thing we should have? We should have this number line, 128, 64, 30. Can you see it? That's the first thing that we are supposed to have. Now, once we have this, we can go to the next thing. So for binary to denary, we know what to do. Then now, as long as you are doing hexadecimal to denary, can you see? So what you must know is that when you are doing, there is a short way. When you go hexadecimal to denary, let's say I want to convert hexadecimal to denary, what I'm going to need to know, I'm going to need to know the same thing. 1, then you say 1 times 16, 16. Then 16 times 16, you get 256. Can you see this? Okay, so we're going to use this, Alex. We're going to use this to then do our conversions. This is the one which we're going to use when we are dealing with our hexadecimal to denary. So binary to denary, you use this. This is for the binary. This is going to be for the binary number system. Okay? Then this is for the hexadecimal number system. We're trying to go to denary. So this is going to be the table we use for the hexadecimal number system. Okay? Can you see this? All right. Now, what we are gonna have now is How do you then convert from hexadecimal to binary? Hexadecimal to binary. Okay, where there's no denary included. Are you seeing this? All right, so now we want to see how do we then do this conversion. The secret is going to be like this. When you now want to do hexadecimal to binary, you must just know that one hexadecimal digit is equal to 4 binary digits. We call them 4 bits. Bits is binary digits, ones and zeros, okay? Binary digits, remember, it's just ones and zeros, right? One hexadecimal will be equal to 4. So what you do is you're going to go to each value and you'll be putting on top of it 8421 on each value, okay? Then you do 8421 again. Then you do 8421. You'll be just doing it like this. Are you seeing, Alex? On each digit. So this will be a digit, okay? This will be a hexadecimal digit. It will be, you use 8421 on each hexadecimal digit, okay? On each hexadecimal digit, we are going to use 8, 4, 2, and 1. This is what we'll be doing. We separate each digit, okay? Are we together? Okay. Now, let's see how we're going to do this. We want to do some questions, and a lot of them from past papers, and we're going to see how to do it, okay? All right. So let's see now. Let's see how it's going to be. So which table are we going to use for hexadecimal and denary? For hexadecimal and binary. Hexadecimal and binary, we use this table. For hexadecimal and denary, we use this table. For hexadecimal and, for binary and denary, we use this table, right? For hexadecimal and denary, we use this table, right? Big one. Then for binary and hexadecimal, we use the idea that one hexadecimal, is 4 binary digits, okay? That's the most important thing to remember. Did you hear the rules that you are not going to break? Remember the secret like we were doing for maths. For you to get something correct, don't break the rules I give you. Just stick to the rules, you'll be fine. So here we want to stick to these rules, okay? Here's what we're going to do, okay? We're going to stick to the rules, and we're going to see where it's going to lead us. We'll stick to these rules exactly how they want us to do. Let's go. So now, one more thing. Let's do questions. Maybe let's go to the past paper questions. First question we want questions to do with hexadecimal, with binary and denary, right? All right, so we want to look for binary and denary. Then we do hexadecimal and denary. Then we do, you understand? Maybe I can even put it at the bottom for you too. Let me just tell you what, let me just give you an example so that you can be fine. I'm going to give you some examples. So let's do some questions together, that then we can go to past papers. Sorry for the gray screen. Okay. So let's do the first question, which we're going to do, Alex, is, let's say they say, so the first we're going to do questions, and the first questions is going to be a conversion between binary and denary. Okay? So it's either binary to denary or denary to binary. What did we say we do? The moment you see binary and denary, you put that table. 2 to the power 0, because binary is base 2, right? Binary is base 2, Alex. Why do we say it's base 2? It only has 2 digits. Okay? Binary only has 2 digits, which is zeros and ones. Isn't? Binary only has zeros and ones. So everything is 2, 2, 2. So say 1 times 2, you get 2. Then 2 times 2, you get 4. Then 4 times 2, you get 8. Then 8 times 2, you get 16. 16 times 2, you get 32. 32 times 2, you get 64. 64 times 2, you get 128. So you have something like this. So if they say to you, Alex, convert, this is the table which you should always use. I don't care whether you're doing binary to denary or denary to binary. I actually don't care. Just use this table. The moment you see those two words, binary and denary, in the same sentence, on the same question, you have to use this table, or else you're going to let us down. So now let's use the table. Let us use the table. There we go. What are we going to say? We'll say, let's say you're asked convert. Okay, I actually am going to copy this table so that I can use it anytime. So let's say you get the question. Question number 1, Alex. Convert denary number 68 to binary. Can you see this, Alex? Denary number 68 to binary. Right. What is it between? What is this question between, Alex? It's between denary and what? And binary. Can you see that? It's between denary and binary. And what did we agree on? Any question between denary and binary, what do we use, Alex? This table here. Yes, don't ever let me down on this table or else it's going to be a problem. The moment you see the words denary and binary, I want to see this table on your working space. So you're going to say, you start with 1 times 2, 2 times 2, 4 times 2, 8 times 2, 16 times 2, 32 times 2, 64 times 2, 128. Are we together, Alex? Then now, you look at the number 64. I want you to keep going until you meet the first number that will be smaller than 68. Okay? Do you hear me? Are you hearing me? Right. I said, what are we going to do? Watch. Look closely. To look at the screen. Okay, it sounds like you're distracted. Are you looking at? Okay, so what is what did I say? We're going to move until we find the first number. That is what? You see, you're forgetting the rules because you're distracted. If you don't know the rules, then we're going to waste time. Listen, Alex, pay attention. I said we are going to move. Remember the first thing. Listen, I want you to tell me these steps, Alex. You're going to tell me these steps. The moment you see the words denary and binary, then you're going to see this. Yes. The moment you see, can you hear me? Okay, good. The moment you see the words denary and binary, then you're going to make this table. That's the first thing. When I see the word denary and binary, if I don't see this table, then you're wrong. You are wrong. If I don't see this table, then you're wrong. All right, so I see this table from you. I know you're serious. You know that denary and binary, the relationship is this table. So what you're going to do, if you're coming from denary to binary, so they'll give you a number. Alex, we have a number 68. Okay, denary number 68. That's the normal number. So what you're going to do, you're going to move on this table until you meet the first value that is smaller than 68. Do you hear me? We're going to move until we meet the first value that is what? Yeah, that is smaller than 68. So we'll be putting zeros until we meet the first value smaller than 68. We start at 1. Alex, we are starting at 128. Is 128 smaller than 68? 128 is not smaller than 68. So what are we going to do? We're going to put a 0 there. Okay? We're going to put a 0. Why are we going to put a 0 there? Because it's not smaller than 68. We're going to keep going until we meet the first value that is going to be smaller than 68. Are you getting it? Okay. So we've got to keep going until we're going to meet the first value that is smaller than 68. What is the next value we have now? 64. Is 64 smaller than 68? Okay? We're going to put a 1. 68. Once you put a 1, you've got to divide now, Alex. So you're going to say 68 divided by 64. This is going to be 1 remainder. What's the remainder? 68 minus 64? 4. So it's 1 remainder 4. Then we take the remainder and we continue our process. We take the remainder and we continue our process. So our remainder is 4, which is going to be smaller than 4. We'll be putting zeros until we meet as values. 0. Here we put 0. Yes. And now we have met a value which is smaller than or equal to 4. It's 4. So we're going to put 1 there. And when we put 1, we come and we divide by that value which we have found. Just like here we got 64, we put a 1, it was smaller than 68, and we came to divide by that 64. So here we put 1 where there is 4, and we come to divide by the 4, and we'll get what? 1, remainder 0. Oh, so when we get remainder 0, you can just finish up with zeros on every one. Okay, because 4 into 4 is 1 remainder 0. So this becomes the binary 0, 1, 0, 0, 0, 1, 0, 0. Have you seen it? Are you sure? Okay. Good. Let's go to the next one. I'm happy now. I'm very, very happy. What about if they say convert binary 0, 1, 1, 1, 0, 1, 0, 0. Then they say, convert this binary number to denary. Convert this. You're going to see. Yes. Well done. You make the table which relates what? Binary. They have a table which works for them. We know that table. Whenever we are doing binary to denary or denary to binary, they have a table. So put that table. The table which relates these two guys. And that table is the, what is that table? You start at 1. Then you say times 2, 2, times 2, 4, times 2, 8, times 2, 16, times 2, 32, times 2, 64, times 2, 128. Is it not, Alex? Now what do you do? So this is no longer a number where you'd look. Yes. Yes. Well done. You take this binary, you lift it, you put it under. So it's going to be 0, then 1, 1, 1, then 0, then 1, then 0, then 0. Exactly. And we are only going to now take the places where we have a 1. We're going to take. So what is it? 64 plus another one. 16 plus the last one, 4. We add them, we get an answer, we are done. So this is 20, this is 52. Oh, that's 56. 20 minus 4. This becomes 116, something like that. 116 around it. So this is going to be 116, and you're done. This is the solution. Can you see it? This is easy, right? This is easy. Is it not easy? So I don't want to see any wrong answer when it comes to the conversion between binary and denary. You saw what we do when we have, let's say, a 68. We just look. Yes. Yes, yes, yes. So here we looked for the first value which is smaller than 68. And when we found it, we divided and we got the remainder. Then we took the remainder and we divided it. We started looking for until we got a remainder 0. You understand? All right, good. Well done. I'm a very, very happy man. So now we continue. So this is what got. This is good. This is good. This is good. Let's see if we can get between binary and between hexadecimal and denary. What did we say, Alex? Let's just do 2, okay? Sorry for that. Okay. Let's now, can you hear me? All right. Let's now do, if we were doing between decimal, we want to see if we're doing between hexadecimal and denary. Hexadecimal and denary. What is the table we use? What is the table we use? Now we want to do between hexadecimal and denary, okay? What is the table we use? We say 1, then times 16, 16, then times 16, 200. This is the one we use. Okay. So hexadecimal, you don't do the table for 1, then you say times 2. No, 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 no. You do times 16, and you do it like this, okay? 600, Alex. This is anytime you see the word hexadecimal and the word denary in the same line, I want to see this. Okay? This is your table. It's no longer binary and denary. It's now hexadecimal and denary. I want to see this table. So now, let's continue. We are now going to say, okay. We are now going to say, all right, Mr. Alex, let's do a conversion. Convert, let's just say, they say AF3. Okay? Convert the hexadecimal value. Convert the hexadecimal value AF3 to denary. Can you see this? They say they've given us a hexadecimal digit, and they want us to convert it to denary. We know that the secret to hexadecimal and denary is having what? The secret to hexadecimal and denary is our table. Remember, for binary, it was the same thing. We had our table for binary. For hexadecimal, we also have our table. And we're trying to do a conversion. So everything revolves around this. Okay? All right, good. So now that we have this, it's going to say, we have this hexadecimal. What are we going to do? So let me explain to you so that you know. What you're going to do for this hexadecimal, for hexadecimal to denary, is just so easy. You're going to say, I have A, I have F, and I have 3. So you'd be saying, okay, you take each value, Alex, you take each value, and you're going to multiply it by its position, so we say. Okay? We take each value, and you're going to multiply it by its position. You know that this is a 3. So let me explain to you what A means in hexadecimal. We have A, we have B, we have C, we have D, we have E, and we have F. So hexadecimal, they call it base 16. That's why everything was being multiplied by 16. It has a total of 16 possible digits. I don't want to over-explain that one. It's unnecessary. But what I just want you to know is that it has the numbers 0 to 9. Then after 0 to 9, it has A, B, C, D, E, and F. A will be representing 10. B will be representing 11, C will be representing 12, D will be representing 13, E will be representing 14, and F is representing 15. So whenever you get a 15, you must convert it to an F. A 14, you must convert it to an E. A 13, you must convert it to a D. A 12, you must convert it to a C. An 11, you must convert it to a B. A 10, you must convert it to an A. So what you should do, you should always have this list to always remind you about hexadecimal. Are we together? Now what we'll do is we'll say, okay, we have A, we have F, we have 3. A is what? If we see on our list, A is 10, right? Then F is what, Alex? F is 15, right? Then 3 is what, Alex? 3 is just a 3, right? It's there, 0 to 9. Is it not? Now what we are going to do is we would now say, this is 256, the third value. We know that. This is 16. We know that. This is 1. So you're going to say, since this is 10, you say 10 times 256. Then you say plus. This is 15 times 16. So it is 15 times 16. Then plus, you now say 3 times 1. So it'll be 3 times 1. What do you get as your total? And you would have converted this number to denary. What do you get as your total? Mm-hmm. Mm-hmm. You can use the calculator for now. What will you get? 2000 and 2643. So now this is becoming your solution. What is the secret, Mr. Clarify? It's the table. The table must be used at all times. Are we together? You multiply each digit by its value. So 256, we have 10 of them. That's what it meant. We have 15 of the 16s and all that stuff. So it's what it is. Now let's say they now give you 600. They say, Alex, can you convert denary 600 to hexadecimal? To hexadecimal. What is the first step? According to our rules, what is the first step that we must make sure we do? According to our rules, the first step is to write the table. You see denary, you see hexadecimal. Oh, these two. It's 256, 16, and 1. Is it not? It is. So now what we are going to do, we do just like we did on denary. We are going to move until we find a value that is going to be smaller than 600. What value is that? Is 256 smaller than 600? All right. But now the difference is you won't put a 1. No. Because for binary, it will always be 1 remainder. For here, you come with the 256 and divide. And tell me what answer you get. Two remainder? No, it's 2 remainder. What is 256 by 2? 256 times 2, what do you get? You get 512. So what is 600 minus 512? No. 600 minus 512. 88. So that means you're going to say this is 2. You put a 2 in here. Then now this remainder, this 88 which remains, you divide it by 16. So you now say 88 divided by 16. I'll get to doing it without a calculator later, but I want you to first master. So what is 88 divided by 16, Alex? You get 5, all right? So now if you get 5 remainder something, I want you to say 16 times 5. What do you get? 16 times 5. What is it? 80. 8 minus 80. What is 88 minus the answer? Because you said it's 5, and by 5 it will be 80. So what is 88 minus 80? 8. So it's 5, remainder 8. So far we have now, we can put a 5 here. Can you see that? and the remainder which remains on the last one, you just bring it here. So that means 600 hexadecimal. So that means denary 600 is actually 258 when it's hexadecimal. Okay? Is going to be hexadecimal 258. Did you see? You saw how I did it? Okay. We'll do a lot of questions and we'll see. And until there's going to be a point where I'll teach you how to do it without your calculator. It's going to be a little bit longer, but it's going to still get you to the answer. So I think I'm fine with that. I trust you on that one. Is going to be binary to hexadecimal. These two, binary and hexadecimal. Remember, one hexadecimal is equal to 4 bits. This is going to be the secret if you want to do anything, okay? So if they say to you, convert, then they give you 10110011, and they say, can you convert this to hexadecimal? What are you going to do? You're going to split it into 4s. You know that to convert to 4 of binary will be equal to 1 hex, right, Alex? So you're going to say it's 10110011. And what do you put on top of them when you convert? You put 8421. Do you remember 8421? 8421. So now, obviously, this becomes 8 plus, where there is a 1 is also 2 plus 1. What is 8 plus 2 plus 1, Alex? That's 11. And what is 11? It is a B. So this is B. You understand? Then here, it's 0, 0, then it is a 2 and a 1. 2 plus 1, because there's 1 on a 2 and there's 1 on a 1. So 2 plus 1 is just 3. So this is B3. So you can already say it will be, so you can say binary, this is us writing, 1011, then 0011 is hexadecimal B3. Have you seen that? All right. What if you now get it as a hexadecimal? A5. Convert A5 to binary. What do you know? You know that this is hex. This is hexadecimal, right? With A's and 5s. Binary is just 1s and 0s. You know that 1 hex should give you 4. So you're going to say, okay, I have A, I have 5, I'll split it. Okay? There should be 4 things here. 8, 4, 2, 1. And there should be 4 things here. 8, 4, 2, 1 as well. Can you see that? Now, how do you get a 5? It's a 4 and a 1. So 4 plus 1. So that means it would be 0 on 8. Okay, you can put the 8421 below the 5 if you want, because you are working it out. 8, 4. Even here, we'll say this is A, which is 10. Okay, by the way, this is A, which is 10. So it's also 8, 4, 2, 1. You put. To get a 5, you can just say, I keep going until I meet the first number less than 5, which is 4. So you put a 1 on a 4, and your remainder will be 1. So you can just say you put 4 and a 1. You understand? Then for 10, what do we put? We put 1 on 8 because 8 is smaller than 10. Then it will be remainder 2. So we put 1 on 2, then it will be 0. So 8 and 2 will give you 10. Can you see that? So what is going to be the final product? You can say a hexadecimal A5 is binary 1010, then 0101. Can you see that? All right. So that's how you do it. Let's go to questions now, and you'll be doing with me. Blah, 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 blah. Then they say hexadecimal to binary. What do you know about hexadecimal to binary? Each hexadecimal will be 4 bits, right, Alex? So we have a 1. Here, this is a 14-bit, so it's like you have a 1, we have a 4, and we have a B. Can you see that? Then what do we do on the 1 and the 4 and the B? Remember, B is what? Check on your list. A is 10, which means B is 11, right? So we have B, which is 11. What do we put below that? Below this, because it's hex to binary, so we put 8421. Here we put 8421. Here we put 8421. So on 1, we know that it's smaller than 8, then 4, then 2, so it will be just a 1. On 4, it will be 0, then 1 on 4, then 0 and 0. Then on 11 now, it will be 1 on 8 because it's smaller than 11, and its remainder 3, which is 0, and you put 1 on 2 and 1 on 1. So it's 1, 0, 1. Can you see that? Okay, so you come here and you're going to put the final solution to say it will be this, Alex, and you put your 0, 0, 0, 1, and you put your 0, 1, 0, 0, and you put your 1, 0, 1, 1. Can you see that? Okay. If you want, you can even separate the digits and write them as 8, 8, 8, 8. That's another story which we'll talk about as well. Let's have 9, 7, 8. So we put 9, we put 7, and we put 8. You gotta separate them because it's hexadecimal and binary. The secret is 1 hex should be 4 bits. Isn't Alex? All right. So each hex is 4 bits. So this is 9, and we can put your 8421. This is 7. You can put your 8421. This is A, which is 10. So you can put your 8421. So what is going to happen on 9? 9 is what? What and what? How do we get 9? Which 2 do we pick on 8421? How do we get 9? Who do we pick? Who and who? We pick 8 and 1. So the others will be zeros. Do you see? Then how do we get 7? It's 4 plus 2 plus 1, 1, 1. Because it's 4 plus 3, which is 7. Do you understand? Then 10. How do we pick a 10? 8 makes it 12, so it's not good. So we put 0. And then 8 plus 2, that is 10. So that's good. So we pick 8 and 2 to get us 10. So now you have it. So it's going to be 1, 0, 0, 1. Then it's going to be 0, 1, 1, 1. Then it's going to be 1, 0, 1, 0. Can you see that? All right. So here, convert the 2 ticket numbers from hexadecimal to denary. What type of number system should we put when we do hexadecimal to denary? Hexadecimal and denary. By 16, which is 1, 16, and 256, right? Those are the ones. So we say this 0 is going to multiply 256 is the third digit, right? Plus these 2 will multiply what? So this is 256, this is 16, and this is 1. Is it not? So you're going to say 256, then you say 2 times 16. Then you're going to say you have a C, which is plus 1 times C. And what are you going to get? Take in the calculator. So open bracket 0 times 256 close plus open bracket 2 times 16 close plus open bracket 1 times, oh, C is not a C. C is a 12, right? A is 10, B is 11, C is 12. So it'll be 1 times 12. So can you put it in the calculator exactly like this? Tell me what you get. What did you say? 44. Did you punch it exactly the way you're seeing it here? That's the exact way you punched it in the calculator, right? All right, so you got 44. All right, okay, good. Then now let's go for this one. The moment you see the words hexadecimal and denary, you're not going to let me down. Please, the instructions are going to guide you. Don't change. The same method we used for maths and we got results. Why would we change now? You see, I want you to be able to tell me that if it's hexadecimal and denary, anytime it's hexadecimal and denary, the table is 256, 16, and 1. If you don't use those three values, you are gone. Okay? 256, 16, and 1. So let's do the 10b now. This one is clearly for 256. This one is clearly for 16. This one is clearly for 1. So you say 1 times 256 plus 0 times 16 plus, what is b? Here. What? B is 11. And what is it multiplying? A 1. So it's going to be times 11 times 1. So what is the answer? 200 and what? 267. Let's go here. Okay, so we have a different scenario. We have now denary to hexadecimal. What do we do here? Is our method going to change? What table do we use when it's denary to hexadecimal? No. No. That's we don't have binary. We can't use 1, 2, 4, 8, 16, 32. We can't. There's no binary here. One to 256. Because there's hexadecimal. The moment you see denary and hexadecimal, it's 1, 16, and 256. What I want is, I would rather have you get stuck on the final solution. I can't have you get stuck on the method. That means we are cooked. We are forever cooked. You can't be stuck on the method. You should know 100% that if it's denary and hexadecimal, it's this table. I don't care where you are starting. Here we were starting at hexadecimal and ending at denary. Here we are starting at denary and ending at hexadecimal, but nothing changes, Alex. We said we don't care where you're starting. If it's the relationship between hex and denary, then the table is 256, 16, and 1. Are we together? Okay. So I want to see 256, 16, and 1. I want to see 256, 16, and 1. Thank you so much. So now, what do we then do? What we know is that denary is counted as a full thing. So this is actually the number 109. Because denary is the real life one, the one we use every day. This is actually the number 415. So what we are going to do in our working space, okay, I think we should have even done these ones in the working space, because the working space is always provided below here. So let's take this away and let's put in the working space. Okay. just take the other one. Why is it fidgety there? There's a lot of background. There's a lot of background noise. Right, can you see this? So you can put your 44 and the 267. Let's do the other calculation now. I mean, we can split the page like this. Let's put it like this. Can you see, Alex? You sure? All right. There's no background noise, right? Right. Let's do this one. Let's do this one, Mr. Alex. 109. So what we do is we start at 109. Remember that we have 256, we have 16, we have 1. Is 256 less than 109, Alex? So we put a 0. Is 16 less than 109, Alex? Okay, so divide them. What is 109 divided by 16? Whole number, or there's a remainder. So it's 6 point something. All right, so it's 6. Now let's get the remainder. Let's say 16. If you want to get the remainder, let's say you got 6 point something. Here's how you get the remainder. You say 109 minus 16 times 6. That's how you get the remainder, okay? What is the remainder? Yes. Punch it exactly like this. I want you to punch it in the calculator exactly the way I've done. Remember, we don't want common sense. We want people who stick to the rules. Punch it exactly like this. Mm-hmm. Did you put it in brackets? So that means this is going to be 6 and you say 13. So it's going to be 6 and 13. Yeah, that's good. What is 13? No. A is 10. B is 11. C is 12. So what is 13? It's D, right? D is 13. So it's 06D. So that means here it would be 6D. Do you understand? You can write it here as 02C. Here you would say 06D. You see? Okay, let's do the other one. 415, Alex. How do we get the answer? I want you to tell me how we get the answer. How do you get the answer? Wait. If we can only, there's one. Look, you can't say it's hard because you know what the reason why you are not getting it. You know the reason, Alex. What is the reason why you're not getting it? What is the difference between this and maths? What are you not doing correctly here? You are not, no, yes, there's focusing, but what me right now? Yes, you don't have the rule. If you had the rule, you would know what to do. Because even if I give you a different one, you will still get stuck. Because what you don't have right now is the rule. Because you should be able to tell me that for this, we do this. You don't have that rule. So you have to listen closely until you get the rule. Once you get the rule, I know you'll be able to do it. I know that. So please get the rule. Here is the rule, Alex. The rule is you must use the table. 16, 1, 16, and 256. Do you hear me? Don't worry about the answer. It will come out on its own. The moment you see the words denary and hexadecimal, you put the table. So put the table. 256, 16, and 1. Can you see that? So we want to know how many 256s were there. How many 16s were there? Here we found out that there were 0 256s because 109 is less than 256. So we put 0 there, but 16 is smaller than 109. So we divided and got the whole number and got the remainder, and we put the remainder as the last position. So where is it hard? Let's start at 415, Alex. Is it bigger than 256? Because, yes, because we are going to use the table 256, 16, and 1. We are going to use it. So 415, this is a denary one. Is 415 bigger than 256? Yes. So that means we are going to divide them. So please divide them for me, Alex. What is 415 divided by 256? What do you get? I want the whole number only. It's 1. All right, good. Now let's get the remainder. If you got one, but how do you get the remainder? What did I say? You start at 415, right? You want to see what is remaining now. You say 415 minus 1 times 256. Yes, 1 times 256. Tell me what the remainder is. So here we already put a 1. It's what? 159. Okay. So here we put 1. Do me another favor. What is 159 divided by 16? Because now we are on 16. What is 159 divided by 16? Nine divided by 16. Punch. Yeah. We put 9 under 16. Are we not? Then what's the remainder? How do you get the remainder? Where do you start? You start at 159. Then you say minus what? 9 times what? No! Minus 9 times what? 9 times this one. Yes. Minus 9 times 16. Because 16 was the one that got in. Minus 9 times 16. What is it going to be? The remainder is 15. You put a 15. And what is 15, Alex, on your number line for hexadecimal? Because we don't write it as a 15. What is it? It's F. Any number bigger than 10, we should change it. So this is F. So what is it going to be? 1, 9, F. Isn't it 1 here? Then it is 9. Then it is F. So where's the problem? Yes. Let's go to another one which says hexadecimal and denary. Here, Alex. By the way, this is exactly a Cambridge paper. So what do they want here, Alex? What did they say? Okay. So do you care about what denary it was and what hexadecimal? Do you care about it? No. What you care about is the word denary and the word hexadecimal. Right, Alex? When you see the word denary and you see the word hexadecimal, I beg, please put for me 256, 16, and 1. Please. Right away, Alex. This is not a negotiation. You do it right away. 256, 16, and 1. Right, Alex? That's the only table we have for hexadecimal and denary. If we don't do it, we are cooked. Now, you come and you see that it is a denary number. They said it is denary number 236. So if it's denary, that means it's the normal one. It's the one which we use in everyday life. So it's the true 236. So this is actually 236. If it was hexadecimal, we would split it. But it's actually 236. So what do we do, Alex? Is 256 less than 236? 256. 256. Is it less than 236? It's bigger, right? So you put a 0. Okay? So now we are starting at 16. Can you now say, what's 236 divided by 16 then? It's 14. It's 14. So now let's get the remainder. You know how to get the remainder. What do we do when we get the... We put a 14 in here, by the way. What is the remainder now, Alex? What is the remainder? Where do we start? Yes, we start at 236. Then we say minus what? 14 times what? Yes, you don't pick numbers from the sky. The numbers are in front of you. This times this. Exactly. It's 12. Okay? And now, what is 14 in hexadecimal? What is it? You should now write A is 10, B is 11, C is 12. Well done. So this is E. What about 12? It's C. So you just come and you do, instead of 14, 12, you write, it will be EC. Okay? Good. So where's the problem, Mr. Man? Good. Let's do one more. Let's do this 415 one more time. Let's make it 416. Alex, let's say this is going to be the last question, then I'm going to give you practice. And the practice is going to be on hexadecimal to denary, because that's the one which was taking you time. Convert denary, because you were not putting the steps. Convert denary 416 to hexadecimal. That's the hard job. Hard job is put the steps. Don't use your mind. We don't want it at all. We have no interest in what you were thinking. We want you to say, because I do. Yes. Because there is denary and hexadecimal, right? Yes. Well done. So you divide. Well done. That's more like it. 416 divided by 256. Okay. 1. Then I want the remainder. Minus. Thank you. That's how you get the remainder. 416 minus 1 times 256. What is the remainder? So in here, you already put your 1 here under 256 because you got 1. What is the remainder? Remainder is 160. Then, thank you. Thank you. So what is it? 160 divided by 16. What do you get? You get 10. So the remainder is 0. So that means the last remainder is 0. You don't have to put anything here. And here you put your 10. So that means the final solution is 1. And what is 10? It's A. So it's 1A. So it is like 1A, 0. Okay, 1A, 0, something like that. Is that okay? All right. Yes, I'm going to pour you with questions. I want to see those questions. What about if they flip it, Alex? They say convert, okay? Because it's similar, but it's a little bit different. If they say convert the hexadecimal, then they give you that one, which we did. Let's go to here. 10B, Alex. Convert the hexadecimal 10B to denary. What do you do, Alex? What is the first step? No, that's not what we do first. Yes, it's true we find what the value be, but what table do we use? When you see hex, yes, well done, because it's hex and this and denary. So it's 1, it's 256, 16, and 1. Well done. Then we put each of them below their position, right? Because they are hexadecimal, so we don't divide, because this is not the real, it's not the real 256, it's not denary, this one. It's hexadecimal, so you put the 1, you put the 0, you put the B. So, and what is B, Alex? A is 10, that means B is 11. So this is actually 11. So let's now do the work. What do we actually do? We now say 1 times 256, right? Then plus, this is 0 times 16. Then plus, this is 1 by 11. Okay, not by B, but by 11. We should change it. What is the final solution? You put in your calculator, you get your answer. 267. And you're done. You're not going to let me down, will you? Good. This is the stuff. I'm going to end it here. You've done well. Want to give you a bunch of questions related to this one, which took us time. Now you know, I always tell you every single day, the secret to us getting to the next stage is when you come, be ready to hear the instructions, apply them, we move on. You're getting used to it slowly, right? It's a painful process. But that has to be done. You have to just get the instruction for every situation. You apply it. We move on. Isn't Alex? Yes. So now that you are applying the steps, that is why the answer is coming. So this is the secret to overcoming education. Steps. Be a man that applies the steps. Everything we agree on, every rule is a must. When you get into an exam, when you get into a test, when you're doing an exercise, every working you do should be according to what the steps said. Don't ever do anything that is not. Are we together? Thank you. I'm going to give you these questions. I'm going to gather my assignment and put it for you. You have to do it, and you have to send it back neatly. Want to see it neat? I want to see the steps. I want to see it. I don't care about the answer. Okay? Whether you get it or you don't, that's another thing. I want my steps. That one is not a negotiable. Are we together? It's a non-negotiable. I want to see my steps, Alex. Remember, Mr. Clarify wants his steps. Okay? Thank you. Goodbye for now. All right.